So this is a setup for our Brewster's angle experiment. So you can see the kind of components we've got. We've got a laser, which we're going to use as our light source for this. Some sheets of Polaroid. I have a prism here, which you can see is mounted on a kind of protractor kind of arrangement, so we can do that. A table, which is just to raise it to the appropriate height. And then at the back I've got a few other things. So I've got a prism, I've got some pile of plates to put in a kind of holder so we can make a pile of plates polarizer, and I've also got a pen tag. So the first part of this experiment is actually just going to be finding the orientation of our sheet of Polaroid that aligns vertically. So you can see there, as I turn this around, it's a little hard to judge which way is the vertical polarization. So there's a good trick we can use, and what I want to do is just get a kind of reflection off the desk. So I've put this lamp in place, and then when I put the Polaroid sheet in place, you'll see there's one orientation where it strongly cuts out the reflection and one where it doesn't. So you see that there? You can still see the reflection, and here you can't. Reflection, none. And that means this is in its vertical orientation now. So what am I going to do next? The next thing I want to do is just align everything we're going to use in the first part of the experiment. So I'm going to turn the laser on. There we go. And then I'm going to just make sure that it's passing through the center of the prism table. Nothing too technical here, really. Just something like that. What you can see here is the reflected laser beam. So I'm just going to turn this protractor back. I just tripped on my shoelace there. So I'm just going to turn this protractor back until that's over the emerging hole for the laser light. See, I've gone too far, and there it is. So this lets us find the zero of the protractor. Now I've dimmed the lights just a little to give this lab more of a feel of being, getting down at the CLISUB, but also so that we can see the laser beam a little more clearly. Here you can see the transmission of the beam. So it's passing straight through the prism at the moment, and it's diffusely reflected there. Now, what we want to notice is what happens when I turn the prism. So you can see there's a reflected beam coming in there. I'm just going to keep turning it. You can see it keeps going. Nothing very interesting happening. Now there it's disappeared from the wall. You can just see it kind of being diffuse there. But that's just because it's striking the edge of the protractor surface. So nothing special happening there. So let's return it back to its zero position. And what I'm going to do now is put the Polaroid in place. So I have this high-tech wooden holder that I'm going to put the Polaroid in. So now you can see the Polaroid is in place, and it's not really having much of a visible effect at the moment. You can see the transmitted beam still going through and striking the back wall. But now let's see what happens when I turn this. So there's our transmitted beam again. And what you can see is, there we go. The beam's disappeared. If I turn it back, you see the beam just very faintly returns, a little further forward. Gone again. If I take the Polaroid away, there's our transmitted beam nice and strong, put it back, it's gone. And of course if I take it and I flip the orientation of the Polaroid, it's oddly difficult doing this behind a camera, you see the transmitted beam remains. So let's flip that again, put it back, and the transmitted beam's gone. So this should have been set up at Brewster's angle now. What we can also do, we can also just have a little look at the intensity of the transmitted beam if I put another sheet of Polaroid in place. So that's at one orientation, and that's at another. So you can tell me in your lab diary which of those would be horizontal and which vertical for this sheet of Polaroid that I've put in place. So we need to take a couple of readings with this. And so what I'm going to do is just take some photographs of the protractor. So I'm going to take a photograph of it in its current position, and then I'm going to take a photograph of it in the 0 position. And of course the difference between the two should give you Brewster's angle. Okay, let's see how we do.